Okay, good morning. This is DeEtta Anderson. I'm having a real hard time recording myself. Hello. For those of you who don't know me, I'm a longtime church member, First Presbyterian member, really long time, and also quite a long-time science teacher at Centerpoint Urbana High School. I am happy to be here today to talk to you about how science and religion intersect my practice of teaching at the high school level. And it's been something I've just enjoyed really talking about in the past, so I'm happy to have this chance to share that with you today. So this won't be a horribly long session because mainly I like discussions. So since we can't really have that today, this will just be a short little informational session, and I would love to have another session sometime where we can sit down and talk about that, and I answer questions and you offer ideas. That would be fun. So I teach all sciences, everything, in a Centerpoint Urbana, which is a smaller rural school, a suburbia school, I suppose. And I've done that for a long time, and I really enjoy my students. I really need people to know about me, and especially my students, that I love science. I love teaching what I do. I love all the topics. I love how I can present it. I love doing lab work with the kids. That is just a huge joy of my life. And I also love religion. I've spent years studying it, maybe denying it at times, but I am a deeply religious person and a person of faith. And so to me, I'm just like a person who science and religion define who I am. And so when I enter the classroom, I can't be anything but authentic. So I'm a person who gets joy from both of those things. And when the topic comes up, or when science and religion intersect with each other, I am more than happy to address it. I address it for a number of reasons. One, I'm authentic. So I'm going to tell the kids when it's appropriate that I'm a person of faith. I think that is a number one thing they need to know. I will not hide that. I won't tell them necessarily what church I go to. I won't tell them what religion I am. But when things come up, and I'm not afraid to say, oh, I was at church the other day and we were talking about such and such. That I share. But I'm very happy to do that, also to be authentic, and because I think it's really important to the development of students' thinking about science and religion. And as they grow and make decisions, I want them to see that the two are very compatible and actually are two beautiful ways to know about the world. So first I'm going to share my screen and hope this works about a little bit of data about science and religion and people's perception. And then I'll go into how I deal with things in the classroom and some specific topics that I deal with in the classroom. So I am going to share a little bit of research that I found. Here's from the Pew Research Group, and it talks about people's perception of the compatibility of science and religion. And in this study, which was done, I think, in 2014, 2015, this pink area in this pie chart shows how many people agree or strongly agree that there's often a conflict with science and religion. Now, I don't know all the ages of the people they surveyed, but I do know that 70% of these younger adults think that often, ultimately, there's a conflict between science and religion. So I'm going to assume that 70% of my students probably think there's a conflict between science and religion. So that's one thing I keep in mind when I think about how I walk in that classroom every day, and knowing an issue might conflict in their minds. And then just some other little interesting tidbits. Of those kids that really think there's a conflict, only about 11% of them belong to a religion that explicitly says that we don't believe in what science says here. And I have those students who deny it. I'll tell you later about a very interesting test answer I got. While a majority of scientists believe in a higher power. So that's just some background information. But I think about this because those are my students. And just another little piece of data here about how often you go to church and do you think there's a conflict? So a lot of my students don't go to church, but they're in this category of the 73% who think that it says, are science and religion often in conflict? And they don't. But those who go to church, well, they're less likely to say that. All right. Stop screen sharing. Pause share. Nope. How do I stop it? No, share. Oh gosh, I'm so sorry. Stop share. There it is. All right, I'm back. Like I said, this is my third time. And the second time my notes fell off my chair. All right. So first thing I do with students, very first day, is I make sure they understand the nature of science. Because in order to understand how science works, you better understand how scientists work and the scientific method. And I don't do a real march through the scientific method like a lot of textbooks do, because I think that's a false method, false way of looking at science. But I make sure that the kids engage in observations, analyses, and very importantly, looking at limits to reliability and validity of data. So they analyze sources of error. And at every age level, you can do this to some extent. I try to get the kids in really good practice. So by the time I have older students, that they're really good at saying, this is what scientists observe, this is how they observe it, these are standard ways of analyzing data, and these are ways that you can take the data and look at it and say, well, is there something there that we need to look at in particular that might limit its applicability, its reliability, or its validity? That last point is so important, because they need to understand that scientists don't prove things. And I even make this a test question, even though it's kind of a ludicrous test question, but we falsify things. So we have a theory, which is something I deal with, a theory, and you have to support or falsify that theory, not support. I don't let any kid with data, I don't let any kid on a lab report ever say, so my data proves the hypothesis that adding baking soda to cake batter makes the cake rise. Because I always start with the microwave cake they make. So they can't ever say prove, because prove to them implies finality. And one thing, the beauty of science is there isn't finality. There is an evolving thought process. And so kids need to know that, because otherwise science becomes very rigid for them. And when it becomes rigid, it becomes kind of like a dogma. And I don't want it to be that, because then you can't see how science could interact with anything beautiful in nature if it's more like a set of rules. So the kids start off at my 9th grade level, for example. I'll start off, they make this microwave cake, and they have to look how they vary the recipe to see how an ingredient affects the outcome of the cake. It's a real simple little thing. I make them write the lab report, because I think it's super important for them to understand what observations are in science and the limits of observations, the limits of data analysis, and the limits of making conclusions. So for example, when we talk about observations in science, we talk about things that you can observe using your 5 senses, except they always want to eat everything. So I tell them that this lab with the cake they can eat, but they always want to taste acids or whatever, it's 9th grade. But so I talk about observations using the 5 senses, and hopefully that sets up a thought in their mind that there is actually a limit to how scientists observe, because every one of them knows about intuition. Every one of them knows about perception of love and perception of things that are intangible, not accessible through our eyes or our ears or our nose. So I really want them to understand that there are different ways of knowing about the world, and one of them is through the scientific method. So I pound that in every lab we do, and we do a lot of lab work. Every lab is about the nature of science, and every lab they're analyzing error and taking a look at how scientists would look at data and change data. So it's beautiful when two different lab teams get completely different results on the same lab, and we talk about, well, in the real world, does this happen with scientists? Yes, it does. Well, what do they do when this happens? Well, you got to go back to the lab table and start testing again. And the nice thing about that is they understand then that science is a process and not a set of outcomes, which leads me then to the word theory. So that's kind of a needle in my side when I hear like evolution is just a theory, or the Big Bang is a theory. Well, they certainly are, but when they use the word just, that implies that it's something that could be tossed out. Like, I have a theory about why you don't like peaches, or something, ridiculous. That is more of a guess, and I make sure that they understand in science we don't, well, certainly we make some guesses, but that a theory is based on observation, and a theory is supported by data, whereas a theory in everyday life might just be a random guess or a thought that passes through your mind and may not be testable. So every time we talk about theories in science, we make sure that they understand that they're testable and have a set of data that support them. You may not agree with the data or the interpretation of the data, especially when it comes to evolution. My kids that are more fundamentalist will not agree with it, but whatever. They need to understand that science works that way. And science really works at trying to falsify data. So if I find out that, this is my favorite one, coconut oil. Remember in the 70s when they took it out of everything because it was going to give us all heart attacks? And then about 5 or 6 years ago, my trainer said, "Oh, you should eat coconut oil." I said, "I will never eat coconut oil. It kills you." And he said, no, it's great for you. And now it's good for people with dementia, and on and on and on. Well, was that data falsified? Was it falsified through research, or was it not good data? What was it? Things change. Certainly, I don't think the data changed much on that coconut oil one, and I still won't eat coconut oil. But it shows that science is a changeable thing, and that when we have some information, let's say coconut oil is related to heart attacks, then every other scientist better go to their lab table and double check that, do a different study, do a study in a different way, look at outcomes for their research, and is that true or not? Because peer review is a process that is integral to science, and that they need to understand too, is that you have to critique and be critiqued by your peers. So nature of science, very, very important. I love doing it, and it encourages kids to really reflect on what scientists are doing and how science might be just a way of knowing. Okay, so the other thing I do is definitely define what is knowable. And I mentioned this a little earlier, but certainly we take a look at things that are knowable through the five senses and things that are not knowable. And this comes up all the time when I talk about the origin of the universe. So the theory supported by data is that there was some kind of beginning and expansion of matter, because it's happening now. Therefore, it must have happened in the past. I make sure kids understand that, but I say, well, are we ever going to really know the beginning of the beginning if we can't observe or have data that supports that? And they sit there and they think about that. I said, so there are some things, I mean, we'll get closer and closer, inching to understanding, but can we know anything before time began, before, we couldn't observe? And the answer is no. We can't know things that are outside the realm of our ability to observe. Well, then, of course, religion comes up, and I'm happy to address it. In fact, I encourage it. I have them look at other things that scientists think about the origin of the universe and the eventual theoretical end of the universe, and what might have been before the Big Bang, because I love outer space. What else is there to think about? What do we not know yet in science? What's the potential for knowing? And it definitely brings up both guesses that scientists have made, not supported by data, but just wild out there guesses. But it also brings up that whole idea of the beauty of universe. As we get closer and closer to knowing, we still don't know, and maybe just can't know by our five senses. That's one thing I love doing the Big Bang. I look forward to it every time because I want kids to ask me about that. And I do recognize, however, that there are biblical literalists in my classroom. And when I teach about evolution, which I do not shy away from, or the universe, the origin of the universe, I certainly don't teach creationism, or I don't talk about creation biblically, but, and I make sure I very, very much couch it as what we know about the origin of the universe. I know there'll be kids that disagree with me, and I bring that up before they even disagree with me, because a lot of kids are too shy. They used to be very vocal about evolution, but now I could beg them to talk to me about it, and they won't, but they'll write me notes. So I gave a test to a kid I knew was very, very much a literalist biblically, and I asked him about evolution, and he said, in parentheses at the bottom, however, this is not true. And I got the biggest smile when I looked at his test, because I thought, why did you not talk to me earlier? Because I would love to engage in a conversation with you. But I think he was afraid of, making me mad or whatever. A lot of times they feel like they're going to be persecuted if they don't believe what the teacher believes or whatever, So, but I do that. Of course, I don't care if he says it's not true. He learned the science, and that's my job to teach him that. But what I wish he would have looked at is some of the beautiful things that go on in the universe regarding the origin of the universe, and open his mind to some of those really, really beautiful things. He's a very, very smart kid, too. I've had students who ask me point blank about evolution. Doesn't the Bible say that's not true? We were all created at the beginning of time. I said, well, tell me a little bit about what you understand of the Bible. So we'll engage in that. And, I have kids that hate religion, but mostly, quite honestly, I'll admit, I have a very conservative community where if they go to church, they're pretty conservative and pretty faithful kids. I teach in Utopia. I have great kids, but they're very polite, very, very nice kids, church-going kids. But I lost my train of thought now that I was talking so much about how much I love my kids. About evolution, we talk about how interesting it is that we can look at the fossil record, and we talk about geologic time and how do we know. And I keep always giving them information. How do we know? I make them seek that information. So how do scientists make inferences about living things from fossilized things that are petrified? And what can they infer, and what are the limits of their inferences? Because they need to know that scientists didn't just come up with the theory of evolution, write down 5 or 6 things that they think fits the theory and everything works. Because it doesn't all work, and there are lots of bits of data that are just confusing to scientists and amazing to scientists and change and modify the theory, and that is the great part about it. So I make them know that inferences can change based on new knowledge, and that's very, very important in changing their view of rigidity of science versus religion. I realize, some will never agree with me, and that's okay. I'm not here to do that. So religion intersects with creation. And so I've mentioned how I enjoy teaching the Big Bang because of that. Religion intersects with evolution because a lot of them believe that the earth was created in 7 days. Fine. But there's also some bioethical issues. Modification of the genome is one where religion comes in. And I engage kids in ethical debates about these issues so that they can flush out, what does it mean to alter the genome? Are we playing God? I let them bring it up. Why not? It's part of what they believe, and it's part of the public debate in society about religion and science, and they need to start developing those ideas. They need to be aware that those ideas are out there and that there's going to be different ways of looking at things. One of my favorites, you wouldn't even think it'd be about religion, is when I'm talking about what temperature is and heat. And we look at the science, kind of science, of freezing your body, cryogenics or cryonics, where people freeze their body in hopes that someday science will catch up and figure out how to unfreeze them and bring them back to life. So I have the kids do research on cryonics. I give them some very leading and questions that really scratch at their ideas of, is this a good thing or a bad thing, a right thing or a wrong thing? And then we engage in a debate. So half of the class goes to one side. They think cryonics or cryogenics is a great idea. The other half of the class goes to the other side, those that think that they would never do this. It's wrong. Through the years, I have found that more and more of the class goes to the don't freeze your body. It's just wrong. And very religious based for a lot of them, but also very practically based. They think it's wrong because you were meant to die. They think of practical things like, well, there'd be overpopulation, natural resources. If you came back 100 years from now, you wouldn't have any family or friends, you wouldn't have a money or a job, and society would be too changed. So sometimes I have to play the devil's advocate and go on the other side and say why I think it's a great idea. And they come up with beautiful reasons why coming back might be a great idea, to share past knowledge, to, if you were a genius musician, you could come back and create, or a scientist, that kind of thing. So here we're talking about temperature and Celsius, Kelvin, and Fahrenheit. And I try to intersperse a debate where it gets at the core of their religion or their deep beliefs, things that science is never going to answer, things like right, wrong, good, bad. And those are things that are answered by their value system. And if I don't bring it up, maybe no one will. And so I consider it kind of, again, I've said it's part of my essence, but it also, I think, is part of my duty. Use of animals in research, changing the genome, like I mentioned before, are they playing God? Climate change is a huge one. I have conservative religious families that do not want me to mention climate change. And honestly, it's been so long, I kind of even forget what the heck they're talking about, why it even intersects with their religion. So knowing that it's a very controversial issue with people that are conservative religiously, I don't present it as anything other than, hey, let's look at some data. And can you find me 10 pieces of data that shows that the climate is changing? Can you find any data that shows that the climate is not changing? Let's take a look at that. What does it mean, climate? What does it mean to change? What time periods are we looking at? What geographic areas are we looking at? Look at all the data and then come to a conclusion. Well, it's not my job to tell them what to believe. It's my job to teach them the science. I can't change family beliefs. I can't change parental influence sometimes, but I can present them with the data, and they can look at the data as easily as me. And I love watching their brains go through like, wait a minute. So the climate went up and down over the last 300,000 years. What's to say it's not going to go down again? I go, I'm not to say that. So, well, maybe it will go down. Okay, maybe it will. Is it going up? Yeah, it's really going up now. I let them look at all the trends, all the data, while trying to keep abreast of current science research and make sure they know the most current things, and let them really reflect on it. Because, I never forget, in 1984, I remember Newsweek magazine, I think it was Newsweek or U.S. News and Report, said, we only have 10 years left. I've kept the magazine. And I show it to him sometimes and go, science in terms of climate is making predictions. And predictions can be right, predictions can be wrong, predictions can be partially right, partially wrong. And we take a look at that so that they understand that science is one way of understanding things and that it definitely can change. But preponderance of evidence shows that we've got some kind of climate change. So I would really at this point like to open up the discussion to questions. So I'm going to quit talking, but I would love to talk with anybody more about this. Like I said, I totally love what I do. I totally love talking about the singularity, the start of the universe. I love thinking about that. I love the beauty of the beginning. I love the whole idea of God creating. And I know my kids know that. I don't even have to say much because I tell them how much I think it's so beautiful. And I tell them about the beauty that I find in nature, in rock formations, in cornfields that we go trumping through, and in creek beds and so on. This is just, this is a beautiful, beautiful world we live in. And they know that beauty is not defined by science either. And wonder and amazement is not necessarily measured by science. So those are the things I hope my students walk out with. And again, I hope to have started the conversation, or at least in their mind, the reflection on science and religion. Thanks for listening. Goodbye.